Welcome to algebra. Here's a little comic to get you started for today. Thought it was cute. Today we're going to take a look at the mean absolute deviation. And we did this last year, so this will be a quick refresher. We're going to look at your notes, and we're also going to look a little bit at this overview. So far we discussed variance, which uses the square of each difference from the mean to eliminate negative differences, and the standard deviation, which then takes the square root of the variance. So two formulas which are known to find the dispersion of data are the standard deviation and the mean absolute deviation. Mean absolute deviation, referred to as MAD, they say is a better measure of dispersion than standard variation, that's supposed to say standard deviation, when there are outliers in the data. An outlier we've already talked about, it's a data point which is far removed in value from the others. So to find the mean absolute deviation, and this is in your notes, find the mean, subtract the mean from each value, same as variance, and instead of squaring it, we're going to take the absolute value and then take the average of those absolute values. It can also be represented by using sigma notation. We are summing the difference of the mean from every value in the data set and dividing by the number of values. And then there's an example that we can work through together. So test scores for 6 students were 85, 92, 88, 80, 91, and 20. So the first thing we're going to do is find the mean. So maybe you would like to pause here and find the mean of those test scores. The mean I got was 76. The next step, we are going to subtract each data point from that 76, and we get those 6 values. Then we take the absolute value of those and divide by 6. So the sum of the absolute values was 112, divided by 6 is 18.7. The mean is going to be less because there was an outlier. Calculating the standard deviation, it's 25.4, and the mean absolute deviation is 18.7. You pause here and just go ahead and do all those steps on your own. So the mean was 85. The deviations are shown. When we added all of those deviations, it was 32, and then we divide that by 6, and we get 5.3 for a mean absolute deviation. Why is it so much smaller in the second problem? And we are missing that outlier of 20. Let's take a look at another analyzing the data. This is not in your notes, but we can look at it here. Both sets of data contain an outlier. The standard deviation for test 1 is greater than for test 2. The mean absolute deviation is larger than the standard deviation for the test 1 scores, or the mean absolute deviation is larger than the standard deviation for the test 2 scores. What do you think the solution is? The standard deviation for the test 1 scores is greater because it has that outlier. Okay? On the back, you have some practice problems. You can go ahead and finish this page on your own, and we'll have some additional practice that you can work on later. Have a great day.